Okay, today we're going to look at power functions. These are different from the types of functions you've looked at before, because in a power function there's no number added. So like a parabola, y equals x squared plus 4x is not a power function because it's got this 4x here. But if you just had the function y equals x squared without the addition on it to make it a polynomial, then that would be a power function. And so if I were to graph the y equals x, the identity function is a power function with a power of 1. Y equals x squared is also a power function, and it's got a point at 1, 1, it's got a point at 2, 4, and it looks like this. If I were to graph the power function y equals x cubed, it would look similar to x squared, but it would just be even steeper. So there's x cubed. Power functions can also have fractional exponents. So another power function would be y equals the square root of x, which is y equals x to the 1/2. And this also has a point at 1, 1. It has a point at 4, 2. It curves this way. And I'd call that x to the 1/2. If I made the power even smaller, like let's say y equals the cube root of x, then it's going to curve even a little bit flatter, y equals x to the 1/3. And so they're this family of functions. They all start at 0, 0. They're all passing through 1, 1, but they're passing through it in different ways and headed in different directions. And if I make the constant negative, they're all going to flip upside down. I'm not going to draw all those for you, but just imagine if the k was negative, they would all flip upside down. Several of your 12 basic functions are power functions. Y equals x is a power function with power 1. Y equals x squared is a power function with power 2. Y equals x cubed is a power function. Y equals the square root of x is a power function. So just like in the last chapter where you had to know all of the different things about your functions, in this chapter you'll have to know all of the different characteristics of each of the basic functions that are power functions. So let's first take a look at this function y equals the square root of x. And I lost my eraser, so we're just going to look at y equals the square root of x. Its domain is from 0 to infinity. Its range is from 0 to infinity. It's continuous. This function is an increasing function the whole time. It is not odd or even, so it's neither. On the last exam, several people for symmetry put the answer yes. That's not the right answer. It's neither odd nor even. This function is bounded below. It has a local minimum at 0, 0, and this function has no asymptotes, and the limit as x goes to infinity of f of x is infinity. It looks like it flattens out, but it does actually get bigger forever. And so you'll be able to you'll have to write all these different characteristics for all your different basic power functions. Also in this chapter, you'll be writing equations for things based on the vocab varies directly, varies inversely, or varies jointly. I wanted to give you an example of varying directly. It's like 1/12, 2/24, 3/36, 4/48. In this example, I take all of my x values and I multiply them by 12 to get y. And they're all going up by the same amount, 12 each time. So y varies directly with x, and the constant of variation is 12. Varies inversely looks a little bit different. As one number is getting bigger, the other number is getting smaller, but it looks more like this. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, 4 times 3 is 12. And so this equation could be given by x times y equals 12, or y equals 12 times x to the negative 1. So in this function, it's considered a power function because I've got this power of x and nothing's added, but it varies inversely because they multiply to the same number. It varies directly is multiplied by the same number. Varies inversely as they multiply to the same number. Now, if I say jointly, I'm throwing like two different things into it. So if I say that y varies jointly, that's not how you spell varies. There we go. Took me to find my eraser. Y varies jointly with x and the square root of z. You would write y equals some constant times x times the square root of z. So jointly is kind of like saying directly, but you just multiply more than one thing. That is all your notes for today. I'm just going to give you some examples. First types of questions are just yes or no, are these power functions? And so if I said d equals 1/2 gt squared, I would look at this, and this has two variables, g and t, but g is a constant. In this case, if you didn't recognize this formula, it's from physics, that's gravity. So because g is a constant, this is really the equation y equals 16t squared, because the acceleration due to gravity is 32 feet per second squared. And so really, the constant is 16, and this is the power. So the answer would be yes, this is a power function. If you had the example like area equals, oh no, let's not do area, let's do perimeter. If you had perimeter equals twice the width plus twice the length, as soon as you realize that it was added, like right here, then you would say, no, that's not a power function, because power functions aren't added. A power function is considered a monomial function if, when you look at the power, like right here, if this is squared or cubed or to the fourth power, if that's an integer that's positive, it's called a monomial power function, and those are some of our basic functions, like y equals x squared, y equals x cubed. You will be asked to analyze power functions, like let's say you were asked to analyze y equals negative cube root of x. So first of all, it is a power function. There's nothing added. It's just the cube root of x, which is it's not a monomial because it's not an integer, because this is actually like negative x to the 1/3, but it still is considered a power function. You would want to sketch a graph of it. At 0, it has 0. At +1, it's +1. At -1, it's -1. And, oh, shoot, we're going the opposite. At +1, it's -1, and at -1, it's +1. And this graph looks something like this. And so if I were to analyze this graph, y equals x, it's the cube root graph, sort of just flipped upside down. Its domain would be all real numbers. Its range would be all real numbers. This is a continuous graph. This graph is decreasing from -infinity to infinity. This graph is an odd function from the spinning thing. This graph is unbounded. This graph has no maximums or minimums, has no asymptotes, horizontal or vertical. The limit as x goes to infinity is -infinity, and the limit as x goes to negative infinity is positive infinity. So lastly, you'll have to read different sentences and write the power function associated with it. Now I'm going to remind you that varies directly means they're all multiplied by the same number. So if you have 1, 2, and 3, and I multiply each of these numbers by 3, the constant of variation, I would get, yeah, not 6. I would get, oh, come on, eraser. I would get 3, 6, and then 9. Because 1 times 3 is 3, and 2 times 3 is 6, and 3 times 3 is 9. So varies directly multiplied by the same number. So in this question, if the surface area of a sphere varies directly with the square of the radius, it equals something times the radius squared. And then there'll be a follow-up sentence that tells you what the constant of this is. Hopefully you can remember it from geometry, but it might say something like the constant of variation is 4 pi. I had to write it out because I don't know where to find the pi on the iPad. So your final equation would be surface area equals 4 pi r squared. 4 pi is a constant of variation, and that's the radius squared. And so this would be a power function. It would be based on the power function with a power of 2. So it's a monomial function, and you should be able to analyze it. The funny thing about the analysis of this one is you're not actually analyzing the graph like you would think of in pre-calculus. You're analyzing the surface area, and surface area can only be positive. So if I had a circle with a radius of 0, it would be 0, but I don't put that point down because it wouldn't be a circle. So this function does not have a point at 0, 0. If I put in a radius of 1, then 4 times pi is 3.14 times 4 is 12 point something. And so I'm going to go up a little bit more than 12. So this function looks like this. Its domain, if I'm filling out all this stuff, its domain is, this is the radius, this is the surface area. Its domain is now going to be given by r is greater than 0. And its range is going to be given by the surface area is greater than 0. And that's different than if I was going to graph this as a parabola. If I graphed this as a parabola, y equals 4 times pi times x squared, the parabola would look like this and have negatives and positives. But because it's surface area, I'm only plus, and in my function analysis, I have to only give the positive values. So when you're analyzing real-life problems, you can only work in the real world.